Change your view to a front view. The stack of work planes and the transitions created in step 17 are displayed. Following the same methodology for the first batch of transitions created in steps 16 and 17, add transitions between the top of riser 2 profile and the smaller top of barrel profile, then the larger top of barrel profile and the bottom of structure profile. You may have to use draw order to send certain profiles to the back, in order to choose the correct one for each transition. The model you created should now look similar to the following illustration. Change your view to SW isometric. Change your visual style to conceptual. Change your visual style back to 2D wireframe, then change your view back to top view. Expand model parameters and size parameters. Note that there are entries listed for the work plane offsets, structure parameters and body diameter dimensions. Right-click Size Parameters and then click Add. The Edit Part Sizes dialog box is displayed, along with the new parameter dialog box. Select Structure Riser Height 1 and press OK. A new parameter of SRZ1 is displayed in the Edit Part Sizes dialog box. In the Edit Part Sizes dialog box, click New to display the new parameter dialog box. Add the following additional parameters using the new parameter dialog box. Structure Riser Height 2. Inner Structure Diameter. Frame Diameter. Frame Height. Cone Height. Slab Thickness. Barrel Height. Barrel Pipe Clearance. Each new parameter is displayed in the Edit Part Sizes dialog box. Click OK. The next step is to assign some preliminary values to the structure parameters. These will be refined later by adding lists of possible structure sizes. Right-click Model Parameters Edit. The Model Parameters dialog box is displayed. Note that the structure parameters have all been assigned an initial value of 0. Change the numbers in the equation column to match the following constants, all in inches. FTH equals 15. SBH equals 84. SBPC equals 72. SBSD equals 168. SBSH equals 315. SCH equals 24. SFD equals 24. SFH equals 18. SID equals 144. SRS equals 300. SRZ1 equals 8. SRZ2 equals 70. SSTH equals 12. SVPC equals 192. These constants can be changed later to variables, lists, ranges, or tables for further part customization. Keep the Model Parameters dialog box open for the next step. Next, you'll change each of the work plane offset parameters, WP of 1 through WP of 5, to correspond with a structure parameter. For example, instead of the first offset being approximately 12 inch, it now corresponds with the SFH parameter. So if you later adjust the SFH parameter, the work plane offset, and its plane geometry, profiles and dimensions, will adjust accordingly. Select WP of 1, and then select Calculator. The Equation Assistant dialog box is displayed. Select the Variable button to use the pull-down to select which structure parameter should match this work plane offset. Click SFH. Press OK to exit the Equation Assistant dialog box. The SFH parameter is displayed under the equation column in the Model Parameters dialog box. Repeat the previous two steps for each work plane offset parameter using the following values. WP of 2 equals SRZ1. WP of 3 equals SCH. WP of 4 equals SRZ2. WP of 5 equals SBSH. Remain in the Model Parameters dialog box for the next step. The following parameters are displayed under the equation column in the Model Parameters dialog box. WP of 1 8.0000 SFH workplane offset 1. WP of 2 8.0000 SRZ 1 workplane offset 2. WP of 3 24.0000 SCH workplane offset 3. WP of 4 120.0000 SRZ 2 workplane offset 4. WP of 5 172.0000 SBSH workplane offset 5. Next you map each body diameter dimension to a corresponding structure diameter parameter. Using the calculator tool in the Model Parameters dialog box, set the equation column for each body diameter parameter making the following matches. BDYD1 equals SFD. BDYD2 equals SFD. BDYD3 equals SFD. BDYD4 equals 2 asterisk SFD. BDYD5 equals 2 asterisk SFD. BDYD6 equals SID. BDYD7 equals SID. The following parameters are displayed under the equation column in the Model Parameters dialog box. BDY01 24.0000 SFD body diameter 1. BDY02 24.0000 SFD body diameter 2. BDY03 24.0000 SFD body diameter 3. BDY04 48.0000 2 asterisk SFD body diameter 4. BDY05 48.0000 2 asterisk SFD body diameter 5. BDY06 144.0000 SID body diameter 6. BDY07 144.0000 SID body diameter 7. Click close to exit the Model Parameters dialog box. Save the part. The part updates to reflect any dimension changes. If desired, change your view to isometric, and your visual style to conceptual, to see how the part is progressing. Change the auto layout location to the center of the rim circular profile. This ensures that the structure is inserted properly into your drawing. Select Layout Data, right-click and then click Select Placement Point. The command line prompts you to select a placement point. Use your node OSNAP to select the point at the center of the rim work plane circular profile. A small, cyan marker is displayed at that location. This marks the structure insertion point. Save the part. At this point, it is important to determine how the new part reacts in a drawing situation. Exit the Part Builder utility by clicking the small X in the upper right corner of the part browser. The part browser is the left pane portion of the Part Builder application window. If you are prompted to save the part, click Yes. Part Builder closes. Open the tutorial drawing called Part Builder 1a.dwg. Click Home tab, Create Design Panel Part Builder. In the Getting Started Catalog Screen dialog box, in the Part Catalog list, select Structure. Select the Junction Structure with Frames folder, and then click New Parametric Part. The New Part box dialog is displayed. For name, enter Cylindrical Manhole 1. Click in the box next to Description. The description matches the name by default. Click OK. The Part Builder parametric modeling environment is opened. Expand part configuration and change the following. Undefined part type, change this to junction structure. Undefined, leave this as undefined. Undefined bounded shape, change this to cylinder. The part is configured as a cylinder shape with the properties of a junction structure. Expand modeling, and then right-click Work Planes and then click Add Work Plane. The Create Work Plane dialog box is displayed. Click Top, and then click OK. The top work plane is created. Expand work planes. Right-click top plane, rename, and change the name to rim. This work plane will be the rim elevation of the new structure. Click Save Part Family. Click Yes. The part is validated and saved. Note that additional parameters are displayed under the Model Parameters and Size parameters to reflect the part configuration settings established in Step 1. Click View tab Views panel front. The view of your part builder drawing area changes so that you see the rim work plane from a front view. Expand modeling. Right-click work planes and then click Add work plane. The Create Work Plane dialog box is displayed. Click Offset. Name the work plane top of riser 1, then click OK. The command line asks you to select Reference Work Plane. Click the yellow bounding square of the rim work plane. The command line asks you to select Offset from work plane. Turn on ORTHO. Select a location approximately 12" lower than the rim work plane in the negative Z direction, and press Enter. In later steps, you will establish a more precise offset by equating these distances with structure parameters. A second work plane is displayed approximately 12" below the first work plane. Repeat steps 2 through 4 to create the following additional work planes, using the following approximate offsets from the referenced work plane. Name, top of cone, offset, 12" below top of riser 1. Name, top of riser 2, offset, 24" below top of cone. Name, top of barrel, offset, 85" below top of riser 2. Name, bottom of structure, offset, 200" below top of barrel. The new work planes are displayed. The new parameters are displayed under Model Parameters, showing you the work plane offsets. Change your view to be oriented above the rim work plane. Expand work planes, right-click rim and then click Set View. The view is oriented to be above the rim work plane. Add a circular profile to represent the diameter of the frame. Right-click the rim work plane, add Profile Circular. At the command prompt, select a center point for the profile at the approximate center of the work plane and a radius of 12", similar to how you would draw an AutoCAD circle. A circular profile is displayed, and an entry for a circular profile is displayed under the rim work plane. Expand work planes, right-click rim, add geometry point. Place a point at the approximate center of your circular profile. A point is displayed at the approximate center of the circular profile. Constrain the profile so that the point will be forced to always be located at the center of the profile. Right-click the rim work plane, add constraints concentric. The command line prompts you to select a first geometry and a second geometry. Select the point and the circular profile. The point moves to be at the center of the circular profile, and a concentric constraint is displayed under the rim work plane. Add a diameter dimension that you can later use as a structure parameter. Right-click the rim work plane, add dimension diameter. The command line prompts you to select circle or arc geometry. Select the circular profile on the screen. The command line prompts you to select a dimension position. Select a location on your screen that is close to the profile, but out of your way. A diameter dimension is displayed on screen as well as under your model parameters. The actual drawn diameter and dimension value are unimportant at this time. Draw a circular profile on the top of riser 1 work plane. Right-click the top of riser 1 work plane, and then click Add Profile Circular. Following the same procedure as step 7, draw a circular profile. You can use your center OSNAP to ensure that the center of this profile matches the center of the profile from the rim work plane. Set the radius to be just slightly larger than the rim work plane circular profile to ease selection of this profile. The actual radius is not important at this time. A circular profile is displayed. Add a diameter dimension to the circular profile on the top of riser 1 work plane. Right-click the top of riser 1 work plane, and then click Add Dimension Diameter. Follow the same procedure as step 10 to place the dimension. A diameter dimension is displayed for your second circular profile. Repeat the previous 2 steps to create a circular profile and corresponding dimension on the top of cone work plane. You have 3 circular profiles with appropriate dimensions. Your dimensions may look different than the following illustration. Repeat steps 11 and 12 to create a circular profile and corresponding dimension for the top of riser 2 work plane. However, this time, make the profile radius approximately twice as large, approximately 24" radius/48 diameter. You should have 4 circular profiles displayed, and 4 corresponding dimensions displayed in the modeling area, and under Model Parameters node. Click View tab Views panel front. 4 profiles from front view are displayed. Add a transition between the rim circular profile and the top of riser 1 circular profile. This represents the manhole cover and frame. Right-click Modifiers and then click Add Transition. The command line prompts you to select Start Profile. On the screen, select the circular profile on the rim work plane. The command line prompts you to select End Profile. On the screen, select the circular profile on the top of riser 1 work plane. A transition is displayed similar to the following illustration. Right-click the transition on the screen, and then click Display Order Send to Back. Add a transition between the top of riser 1 circular profile and the top of cone circular profile. This represents the manhole cover and frame. Right-click Modifiers and then click Add Transition. The command line prompts you to select Start Profile. On the screen, select the circular profile on the top of riser 1 work plane. The command line prompts you to select End Profile. On the screen, select the circular profile on the top of cone work plane. Repeat the process to create a transition between the circular profiles on the top of cone work plane and the top of riser 2 work plane. Remember that you may have to use Display Order Send to Back to send the transitions to the back, so that you can choose the profiles. To do this, right-click the transition on the screen, and then click Display Order Send to Back. Transitions are displayed similar to the following illustration. These transitions stay dynamic to profiles used to create them, including adjustments to work plane offsets and diameter dimensions. Switch your view back to an overhead view by selecting the top of barrel work plane, right-clicking and choosing Set View. Your view switches to an overhead view in relation to this work plane. Make 2 circular profiles with corresponding dimensions on the top of barrel work plane. Use steps 11 and 12 for reference. The first should be approximately the same size as the profile on the top of riser 2 work plane, 24-inch r/48D. The second should be approximately twice as large, 48 r/96D. 2 circular profiles are displayed on your screen. 2 corresponding dimensions are displayed both on screen and under model parameters. Make 1 circular profile with a corresponding dimension on the bottom of structure work plane. Use steps 11 and 12 for reference. The profile should be approximately the same size as the larger profile on the top of barrel work plane, 48-inch r/96D. You should now have 7 total circular profiles and corresponding dimensions both on screen and under model parameters. Remember that these diameters are approximate at this point. The ones you created may not look exactly like the ones displayed in this tutorial. Do a quick visual check on the Part Size Creator dialog box to verify that all values are non-zero. If any of the properties are displayed in the Part Size Creator dialog box as 0, the part will not insert into the drawing properly. Now add a few pipes to your test parts list. Exit the Parts List dialog box. A new parts list is created. Create a pipe network by layout that contains approximately 3 structures and 2 pipes. Observe how your structures are displayed in Plan, 2D, Views and in 3D View, Object Viewer. Click Home tab, Create Design Panel Part Builder. Select Manhole 206 Type A, and then click Modify Part Sizes. Part Builder opens to your custom part. Add some variables to the cone height, SCH, riser 1 height, SRZ1, and barrel height, SBH, to make it easier to edit your structure after it has been inserted into the drawing. Right-click Size Parameters and then click Edit Configuration. The Edit Part Sizes dialog box is displayed. Under SCH, SRZ1 and SBH, change the data storage from constant to list. Each parameter now accepts additional values. Click Values from the drop-down list at the top of the Edit Part Sizes dialog box. The Edit Part Sizes dialog box switches to Values mode. Move your cursor to become active in the SCH column, and then click the Edit button from the Edit Part Sizes dialog box toolbar. The Edit Values dialog box is displayed. Click Add to add the following values, 0, 6, 12, 18. Click OK to exit the dialog box. A list of values is now available for SCH. Repeat steps 16 and 17 for SRZ1 and SBH, adding the following values to each list. SRZ1 equals 12, 24, 36, 48, 60. SBH equals 100, 120, 140, 180. Click OK to exit the Edit Part Sizes dialog box. Lists of values are now available for SRZ1 and SBH. Save your part. Additional customizations can be made to the geometry of a manhole such as this one using the principles learned in the vault structure tutorial exercise, as well as other part building exercises. Exit the Part Builder utility. Click the small X in the upper right corner of the Part Browser. The Part Browser is the left pane portion of the Part Builder application window. If you are prompted to save the part, click Yes. Part Builder closes.